Am I the only one that didn't know even the biggest projects can fail? Turns out, perfection is an illusion. Let's uncover why. You see the shining skyscrapers and epic bridges, but behind every mega project is chaos, unexpected disasters, wild challenges, and solutions nobody saw coming. Today, we're pulling back the curtain on the untold battles that turn blueprints into battlegrounds. Every mega project begins with a dream. Architects present gleaming models, politicians make grand promises, and investors see nothing but success. The blueprints are flawless, every measurement precise, every calculation verified. But then reality strikes. The ground isn't what the surveys promised. Underground rivers appear where none were mapped. Rock formations prove harder than diamond. Take the Channel Tunnel. Connecting Britain to France seemed straightforward enough. But 40 meters below the seabed, French and British teams discovered their tunnels were heading in completely different directions. The most advanced surveying equipment of the 1980s had failed them. They were off by several meters. When they finally broke through, it was pure luck they met at all. London's Millennium Bridge was supposed to be a symbol of engineering excellence entering the new century. Thousands gathered for the grand opening. What could go wrong? Within minutes, the bridge began to sway. Not gently, violently. People grabbed the railings, some fell to their knees. Officials had no choice but to close the bridge immediately, 2 days after opening. Engineers embarked on a journey of discovery, meticulously analyzing the bridge's behavior. They soon discovered something quite unexpected, something no one had predicted in their initial calculations: synchronized walking. It turns out that when people walk together, especially in large groups, they naturally and unconsciously fall into step with one another. This seemingly innocuous behavior would prove to be the key to understanding the Millennium Bridge's wobble. This collective stepping created a resonance frequency, a rhythmic force that, unfortunately, matched the bridge's natural sway. It was as if the pedestrians themselves were amplifying the bridge's inherent tendency to oscillate. Physics, in a cruel twist of fate, turned ordinary pedestrians into an unwitting demolition crew, their combined footsteps threatening the structural integrity of the very bridge they were crossing. The solution to this unforeseen problem was both ingenious and substantial. 91 dampers, sophisticated devices designed to absorb and dissipate energy, were installed underneath the bridge. This extensive retrofit came at a considerable cost, £5 million to be exact, all to fix a problem that no one had anticipated or even conceived of during the initial design phase. Today, the bridge stands stable and secure, a testament to the ingenuity of engineers and the power of understanding complex systems. But it took 2 long years of intensive research, design modifications, and a complete rethink of conventional pedestrian bridge design principles to achieve this stability. But sometimes the solutions come too late. The Tacoma Narrows Bridge, nicknamed Galloping Gertie, seemed fine during construction, until a 42-mile-per-hour wind turned it into a giant guitar string. The bridge began oscillating wildly. Within hours, the entire center span collapsed into Puget Sound. 4 months after opening, this disaster revolutionized bridge design forever. Wind tunnel testing became mandatory for all major bridges. Today's mega projects face even more complex challenges. Climate change brings unprecedented weather patterns, floods where deserts used to be, hurricanes stronger than ever recorded, ground that shifts with changing temperatures. But we're fighting back with technology our predecessors could never imagine. Sensors that predict structural stress before it happens. Artificial intelligence that can spot problems in blueprints before ground is broken. But behind every solution, every breakthrough, every disaster averted, are the people who refuse to give up. Engineers who work 20-hour days to solve problems that have never existed before. Teams that bring together expertise from around the world, combining ancient wisdom with cutting-edge technology. And sometimes, in the darkest moments, they find solutions that change everything. The future of megaprojects promises to be an era of unprecedented ambition, pushing the boundaries of what's currently conceivable. We stand on the cusp of tackling even bigger challenges than ever before. Imagine cities floating serenely on water, defying gravity and conventional construction. Picture bridges spanning entire continents, uniting cultures and economies in ways previously unimaginable. Envision tunnels burrowing deep through the Earth's core, unlocking resources and secrets hidden for millennia. These are not mere fantasies, but potential realities. To achieve these monumental feats, we're diligently developing materials stronger and more resilient than anything nature has ever created. Consider self-healing concrete, capable of repairing cracks and extending the lifespan of structures indefinitely. Think of steel that grows stronger under stress, adapting and reinforcing itself against immense pressures. These innovations are crucial. But amidst all this technological advancement, one fundamental aspect of human nature will never change. The moment we think we've solved every problem and conquered every obstacle, the next seemingly impossible challenge inevitably appears on the horizon, beckoning us forward. And somewhere, in universities, workshops, and labs around the globe, a new generation of brilliant and dedicated engineers is diligently preparing to turn today's perceived impossibilities into tomorrow's groundbreaking realities, shaping a future we can only begin to dream of. So, the next time you gaze upon a towering skyscraper that seems to pierce the clouds, or witness a bridge gracefully defying gravity with its elegant span, or even as you travel through a tunnel boring deep beneath seemingly impossible terrain, take a moment to remember this. What you're seeing isn't just concrete and steel, or glass and cables. It's the culmination of countless hours of planning, problem-solving, and unwavering dedication. It's human ingenuity, triumphing over the seemingly impossible, pushing the boundaries of what we believe is achievable. It's a testament to our relentless spirit of innovation. Every megaproject is, in essence, a grand battle. A battle between human ambition, our innate desire to build and create, and the unyielding laws of physics that govern our universe. And somehow, against all odds, facing setbacks and overcoming unforeseen obstacles, we consistently keep winning. We continue to redefine what's possible. The initial blueprint was just the beginning, a mere starting point in an epic journey. The real story, the truly captivating narrative, lies in everything that went wrong along the way, in the challenges we faced and in how, through collaboration, perseverance, and sheer grit, we ultimately made it right.